Hello students, my name is Sumit Mehta. So in today's lecture we will discuss about maxima and minima. Okay. So let me first tell you how what are the definitions of maximum functions or the maximum value of a function in the given defined range. Okay. So let's say let f be a function defined on an interval I. So the function is defined in between this interval. Okay. So the first point is f is said to be said to have a maximum value in I if there exists a point C, if there exists a point C in I such that fc is greater than fx. Means at C the value of the function is maximum for the number fc is called the maximum value of I of f in I if there exists a point C in I such that fc is less than fx, and f in I and the point C is called and the point C is called maximum value of f in I. Okay. Similarly, the same definition holds true if fc is less than fx for all x belongs to I, then fc is called the minimum value in this case. fc is minimum value. Okay. And the third point is f is said to have extreme value in I if fc is neither maximum or nor neither maximum nor neither is either maximum or minimum value. Means it is called to be extreme value if it is either maximum value or either minimum value. Okay. So students, there are two tests to check the function whether it will attain a maximum value or it will attain a minimum value. So the first test is to check the first derivative. So student, I am writing about the first derivative test. So first there is a prior condition. Let f be a function defined on an open interval I. Let let f be continuous at a critical point c in I. Okay, then we can say that the first point is if f dash x changes sign from positive to negative as x increases, though c through c, that is if f dash x greater than 0 at every point sufficiently close to. Student, these are the definitions. I'll in the last I will say the crux of the matter what we have discussed. Okay, so these definitions you should know. Okay, and to the left of C and f dash x less than 0 at every point sufficiently close to. So student, this is a condition like this. Let f dash x changes signs from positive to negative as x increases through c. Means f dash x here it is greater than 0. As you can see, the slope of this function is greater than 0. Okay, and here it is negative. So this c point is local maximum. The second point is again similar condition opposite. If f dash x is greater than 0 at every point sufficiently close to the right of c, then c is told it is local minima, and to the left of c the slope is negative, means f dash x is less than 0 here. Okay, and the third point is which I want to discuss. If f dash x does not change sign as x increases through c, then c is neither a point of maximum or local minimum. In fact, such a point is called point of inflection. Point of inflection means it is neither a point of local maxima or local minima. Now let's discuss, student, the second derivative test. So second derivative test means we need to derivate the function two times. Okay, the necessary condition, let f be function defined on an interval I and C belongs to I, let f be twice differentiable function at C. Because it is the second derivative test, the first condition is x equal to C is a point of local maxima if f dash c equals 0 and f double dash c at this point is negative. The value fc is local maximum value of f. Second, x equal to c is a point of local minimum or local minima, you can say, if f dash c is again 0 here and f double dash c is greater than 0. So in this case fc is local minimum. And the third point, which is the test fails if f dash c equals 0 and f double dash c is also 0 at a certain point. Okay, so this is the second order derivative test. Okay, student. So I hope now you are pretty clear about what is the first derivative test to check whether the function attains its maximum value or minimum value, and it is the second derivative test. And in the next lecture, student, we will discuss some questions based on it. So stay tuned for that lecture. Thank you. Happy learning.